Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an interesting problem with complex numbers. So we are given a complex number z whose cube is equal to 8, and we're supposed to find z sub 1 times z sub 2 times z sub 3. What is that supposed to mean? Well, in the complex world, we have a cubic equation and it has three complex solutions. So those numbers represent each of these solutions, and the answer is how do you find their product, right? So I'll be presenting more than one method. So let's start with the first one. By the way, if you like algebra, number theory, and trigonometry problems in addition to complex number problems, go ahead and check out my other channel, Cyber Math, that is cyber with an S. All right, let's get going. To solve this problem, I'm going to try to solve for z. And basically, like I said earlier, this equation has three solutions. And then once I find all the solutions, I'm going to multiply them. How do you find these solutions? How do you solve z cubed equals 8? Well, isn't it just q cubed root both sides and you get z equals 2? That's true in the real world. In the complex world, we have two more solutions. So in this case, we are looking for complex cube roots of 8, which could be represented as 8 to the power 1/3, and this is basically multi-valued. There are three values that satisfy this. 2 is just one of them, okay? So you can call this z sub 1 if you want, but you still need to find the other two solutions, okay? And let's see how we can do it. There's a couple ways to go about it. One method is, which is probably something that you'll almost never use, is since z is a complex number, and what is the name of this channel? Don't ever forget, okay? It's A plus BI. So set z equal to A plus BI, and then cube both sides. That's going to give you A plus BI to the third power, and then set it equal to 8. And then from here, try to find the values of A and B. And good luck with that, because that's going to take forever. But obviously, you can expand it, and these two numbers are going to equal, which means the imaginary part on the left-hand side is also going to be 0, like here. And the real part is going to be 8, so you'll get a system of equations with two variables. You should be able to solve it, right? Yeah, that's going to be complicated, though. You don't want to do this, but I still showed you what that looks like, okay? A better way to do it is using the polar form of a complex number. While 8 in the complex world can be written as 8 times e to the power 2 pi and I, where n is an integer. And I is, oopsies, I forgot to say, I is the square root of -1 because I squared is equal to -1. Okay? I is the most important part and I forgot that. Sorry about it. Now, n is an integer, but you don't have infinitely many values for n. You only need 3 because this number has 3, or this equation has 3 solutions, right? So how do you cube root both sides? Easy. You first cube root 8, which in this case happens to be the modulus or the absolute value, which is 2. And then you cube root the exponential, which means you raise it to the power 1/3. So it's going to look like this. E to the power 2 pi and I divided by 3. Now, let's pick n equals 0, 1, and 2. Obviously, if you pick n equals 0, you're going to get z equals 2, which is already something we talked about. What happens to if n is equal to 1? Then you get z equals 2 times e to the power 2 pi I over 3, or you can write it as I times 2 pi over 3, which makes more sense, and I'll show you why in a little bit. So if you want, you can call this z sub 1, this z sub 2, and the last solution is going to come from n equals 2. z3 is going to be 2 times e to the power I times 4 pi over 3. When you replace n with 3, it's going to cycle back here because it's going to be 6 pi over 3, which is 2 pi, which is the same as the 2. So notice that here, I use the fact that this indeed represents 1, right? So this is, in other words, the complexification of 1. How can you write 1 in the complex world? Obviously, there are multiple representations, right? Great, so since these are all the solutions, couldn't we just multiply them together? Sure, but let's go ahead and take a different route because I want to show you what each of these are. So Euler said e to the power I theta, and this is the most beautiful equation that you can ever imagine. There's nothing better than that. So e to the I theta can be written as cosine theta plus I sine theta. Make sure you know this formula, okay, because it's beautiful. Great. Now, what happens if you replace I with 2 pi, I mean theta with 2 pi over 3 and 4 pi over 3? In other words, e to the power I times 2 pi over 3 becomes cosine 2 pi over 3 plus I times sine 2 pi over 3. And what does 2 pi over 3 represent as a degree? If you think about it, it's 2 times 60 degrees or 120 degrees. So we're talking about this angle right here on the unit circle. And if you look at its cosine and sine, then Z2 is going to look like this. This is going to be negative 1/2, and this is going to be root 3 over 2 multiplied by I. When you look at the 4 pi over 3, you're just going to double 120, which is going to give you 240. And 240 is going to be here, right? And then they're going to have the same cosine value, but different sine value. So Z3 is just going to be negative 1/2 minus root 3 over 2 multiplied by I. And of course, you can use the sigma notation, so on and so forth. By the way, these are not the solutions because I forgot to multiply by 2. So what you need to do is actually multiply both of these by 2. I forgot the modulus. And when you do that, you're going to get negative 1 plus root 3i, which is actually really cool. And this will give you negative 1 minus root 3i. Now, I got all the solutions. Z1 is equal to 2. Z2 is equal to negative 1 plus root 3i. And Z3 is equal to negative 1 minus root 3. If you hear some meows, that's one of my cats. But anyways, if you multiply these three things, they always need attention, don't they? You're going to get the solution. But to multiply these two things, you can actually take advantage of one fact, that difference of two squares will help you. Kind of like a plus bi and a minus bi. But be careful, because when you multiply these two things, you get a squared plus b squared. You're supposed to get sum of two squares, I mean difference of two squares, but I squared is equal to negative 1. Instead, you get sum of two squares. In other words, this is going to become 1 plus 3, which is 4. Great. And then if you include the z1 here, z1 times z2 times z3 is just going to be 2 times 4, which is equal to 8. So it's kind of easier to multiply these two first together, or you could also do it all together, no big deal. But the answer is supposed to be 8. Well, isn't there another way to look at it? Absolutely. You don't have to do it this way. You could multiply directly in polar form. And that's actually a really good advantage, because multiply the moduli, 8. And then you're going to, when you multiply these two exponentials, you're going to add the exponents. It's going to be e to the power I times 6 pi over 3, which is 2 pi. And like before, this is 1. Remember the complexification process. The answer is going to be 8 again. But again, this is not the best way to do it, right? This is kind of like a very roundabout method, but that's what we do with the first method. No pain, no gain. Let's go ahead and talk about the second method. And actually, thinking about the second method, I can also think about a third method, okay? So here's the second method. I got this equation. Why not subtract 8 from both sides and then factor this using difference of two cubes, which is z minus 2, and then z squared plus 2z, or not 2z, that's the problem, plus 4 equals 0. And from here, what are you going to get? You're going to get z equals 2 as normal, as usual. From here, using the quadratic formula, negative b plus minus the square root of b squared, which is 4, minus 4ac, which is 16. And then you're going to subtract and divide by 2a. This is going to be negative 12. It's going to be 2 root 3i, and then divide by 2. And that's going to give you negative 1 plus minus root 3i, which are the same solutions as before, obviously, right? Of course, you're not going to get anything different with different methods. You shouldn't be normally, right? So always check it out. Now, that's the second method, and multiply those together. You know the drill, right? Let's go ahead and talk about the third method, because I think that was the whole purpose of this problem. I wanted to emphasize something that actually I made a video on my other channel, which is cyber math. And what is that? That is called Vieta's formulas. So Vieta said, if you have a cubic equation, let's go ahead and write it down in the complex version, az cubed plus bz squared, az cubed plus bz squared plus cz plus d equals 0. And as you know, the solutions are z1, z2, z3. Vieta said that, okay, the sum of the roots is negative b over a, and the product of the roots is negative d over a. Of course, there's a two-way product, which I'm not talking about, but this is what you are concerned with. You don't really care about the other things. So what is that supposed to mean? If you want to find the product of the roots in a cubic equation, all you have to do is take the constant term and negate it, this is what it means, and divide by the leading coefficient, which is a. But notice that in this case, the leading coefficient is 1, and our constant term d is negative 8. So what am I supposed to do? Take the negative 8, negate it, and divide the answer by leading coefficient, which is 1. So in other words, you're going to negate negative 8 and divide by 1. So the product of these roots is going to be 8, positive 8. And you didn't need to solve the equation to find the product of the roots thanks to Vieta. And Vieta, I don't know how it's pronounced properly, is a French mathematician. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out Cyber Math and A+BI. And bye-bye.